Good morning, friends and my dear children. I hope all of you are doing better. Today in this video we are going to learn about decomposition reactions. Okay, and types of decomposition reactions. Okay, this is one of the important topics of language of chemistry. Okay, before we come to know about big topics of chemistry. Okay, we all should learn about types of chemical changes. Okay, so in the previous video we have learnt about chemical combination reactions. Okay, and in this video we are going to learn about chemical decomposition reactions. Okay, then without any delay, let us start our topic. Okay, right, today's topic is what? Chemical decomposition reactions. Chemical decomposition reactions. Okay, so what is meant by chemical decomposition? In the name itself it is there. Okay, decomposition means dissociation. If a single substance splits into two or more substances, either by heating or by sending electricity or by keeping them in sunlight, okay, then if it gets dissociated into simpler compounds, then such kind of reactions in which single substance splits into two or more substances, then such kind of reactions comes under the category of what? Yes, decomposition reactions. Okay, so what is the definition for decomposition reactions? Decomposition can also be treated as what? Dissociation reactions. Decomposition means what? If a single substance splits into two or more substances. Okay, if a single substance splits or dissociates, splits in the sense dissociates, splits into two or more substances, okay, then such kind of reactions are called as what? Decomposition reactions. That means what? Reactant is one, but products are many. Reactants gives rise to products, that you know, isn't it? In any chemical reaction, reactants gives rise to products. Here reactant is only one compound, but products are many. Then one reactant gives rise to many products. Such kind of reactions comes under the category of what? Chemical dissociation reactions or decomposition reactions. Okay, so we will be learning about different types of chemical reactions which comes under the category of what? Decomposition reactions. That means types of decomposition reactions. So what are the different types? Types of decomposition reactions. Types of decomposition reactions. Okay, so what are the different types of decomposition reactions? So we have three types of decomposition reactions. They are thermal decomposition. First category are what? Thermal decomposition. In the name itself it is there. Thermal. The word stands for what? Yes, heat energy. Okay. Thermal decomposition reactions. Then photolytic reactions. Photochemical or photolytic. Photochemical reactions. Okay. And then third category is what? Electrolysis, by passing electricity. Electrolysis reactions. So decomposition can be three types. First one is what? Thermal decomposition. Second one is photochemical decomposition. And third one is what? Electrolysis reactions. Okay. Now let us learn one by one about each type of decomposition reactions, and we will be learning certain examples also. Okay, so first let us focus on what? Thermal decomposition reactions. That means what? The decomposition that takes place with the help of heat energy. first category are what? Thermal decomposition reactions. If the decomposition takes place with the help of heat energy, by heating a substance, if a single substance splits into two or more and gives many products, then such kind of reactions which gets dissociated by heating, you call such reactions as what? Thermal decomposition reactions. Okay, decomposition which occurs due to heat energy. Decomposition which occurs due to what? Heat energy are called as, which occurs due to heat energy are called as what? Thermal decomposition reactions. Okay, let us see examples. Okay, see here, if you take certain kinds of substances, like if you take carbonate salts, okay, carbonate salts on heating, they gives rise to their respective oxides and carbon dioxide gas will be liberated out. Okay, and at the same time, suppose if you take nitrate salts, then they get dissociated into what? Their respective oxides. Oxygen gas will be produced, and at the same time nitrogen dioxide gas is also being liberated. Okay, so like that, depending on the type of salt which you have taken, okay, that respective gas will be released and the respective oxide will be formed. Okay, suppose if you take carbonate salts like CaCO3, you all know that it is what? Calcium carbonate. Okay, limestone, this can also be called as what? Limestone. On heating, it gives rise to, this triangle symbol on the gives rise to arrow indicates what? On heating. We are learning about what? Thermal decomposition. So on heating gives rise to what? Calcium oxide plus carbon dioxide. Carbon dioxide is the gas released. Okay, so if you take carbonate salts, they will give carbon dioxide gas and respective oxide also will be coming out. Here calcium oxide, CaO means what? Calcium oxide, which is also called as what? Quicklime. Okay, quicklime. Okay, this is the best and first example for what? Decomposition reaction. Calcium carbonate on heating, it gives rise to what? Calcium oxide and carbon dioxide. Right? Then we will go for the next example. Okay, so let us learn second example. Even if you take lead carbonate on heating gives rise to lead oxide plus carbon dioxide. Okay, lead carbonate gives rise to lead oxide plus carbon dioxide. Okay, in these two cases I was telling you about the liberation of carbon dioxide. How can you say that the gas liberated is carbon dioxide only? Okay, here lead carbonate and lead oxide is what? Pale yellow in color. Even in the previous video also we have learnt. In the combination reactions also we have come across this lead oxide. Okay, pale yellow in color. Right? Lead oxide can be even red lead oxide also will be available. Orangish shade, red lead oxide. Okay, so here how can you say that the gas liberated is carbon dioxide only? So test for CO2. You all know this. You were learning this from your lower classes. Isn't it, dear children? Did you remember what is a test for carbon dioxide? I mean, how can you say that the gas liberated is carbon dioxide only? Because carbon dioxide is a colorless gas and oxygen is also a colorless gas. Then how can you say that so and so gas which is liberated is carbon dioxide only? Means you need to test like this. Okay, so what is the test for CO2? Carbon dioxide, CO2 turns lime water milky. This point you all know. CO2 turns lime water milky. Means what? If you are passing carbon dioxide gas through lime water means what? Yes, calcium hydroxide solution. You call it as lime water. Okay, even if you take lemon water, then also it's okay. Here you need to understand the difference between lime water and lemon water. I am speaking about lime water here. Lime water means it is calcium hydroxide solution, chemically called as what? Calcium hydroxide solution. Okay, so if you pass carbon dioxide gas through calcium hydroxide solution, calcium hydroxide actually it is colorless. This is called as what? Slaked lime. Please remember the common names also. Slaked lime. Okay, it's a colorless solution. Aqueous, AQ. Down if you keep AQ, it indicates what? Aqueous. Okay, aqueous solution of calcium hydroxide if you take, and if you are passing carbon dioxide gas through it, then it gives you a milky white precipitate of what? Calcium carbonate will be formed. Okay, CaCO3 is the milky white precipitate formed. Okay, when you pass carbon dioxide through lime water. Okay, if you find the formation of this milky white precipitate, okay, now milky white precipitate, if you find, then you can say that the gas liberated is carbon dioxide only. Okay, this is the test for what? Carbon dioxide gas. Okay, that means carbon dioxide turns lime water to milky white substance. What is that milky white substance? Yes, calcium carbonate is the precipitate formed. That's why carbon dioxide turns lime water milky. Okay, so in this regard, you will be getting certain questions in the form of X, Y, Z. A substance X, when made to react with carbon dioxide, another substance, a milky white substance Y, is going to form. Okay, identify X and Y and write the relevant equation, balanced equation for the reaction. Like that you will be getting questions. Okay, now way of questioning also you should understand. Just knowing the reaction everybody can do. At least by learning or getting it by heart, everybody can remember. But the way of questioning, you have to identify the substances X and Y. Okay, most of the questions they'll be asking in the form of X and Y only. Okay, even they may ask like here, what is a gas liberated? Means even this kind of questions, this reaction or this reaction can also be asked in the form of XYZ questions only. Okay, when white colored substance when heated, it gives rise to its respective oxide, and a gas Y is released, which is released with brisk effervescence. Even they may ask like that also. What is brisk effervescence? Okay, brisk effervescence means a kind of gas will be liberated quickly, okay, and escapes quickly to the surroundings. Okay, so brisk effervescence, if they ask like that, then also you should identify the gas to be what? Carbon dioxide only. Okay, so like that you'll be getting questions. Okay, way of questioning, please try to understand. Okay, even in Olympiads also, or even in your normal board exams also, the way of questioning is very much important. Understanding the way of questioning is very much important. Okay, so this is the test for what? Carbon dioxide gas. Same like that in the decomposition reactions, you can even learn, as just now I told you, nitrate salts may gives rise to what? Their respective oxide. You can take second example for decomposition reactions. KNO3, potassium nitrate. On heating, it gives rise to what? Potassium nitrite, KNO2 plus oxygen gas is liberated here. Okay, KNO2 plus O2. You can balance the equation by keeping 2 here as well as 2 here. 2 potassiums, 2 potassiums, 2 nitrogens, 2 nitrogens. 6 oxygens, 4 plus 2, 6 oxygens. This is potassium nitrate. Potassium nitrate salt. Okay, on heating, it gives rise to potassium nitrite and oxygen. Potassium nitrite and oxygen gas is liberated. Even here also, oxygen is a colorless gas. then how can you say that the gas liberated is oxygen only? Okay, because all nitrate salts will not only give oxygen gas. Some of the nitrate salts will be giving even nitrogen dioxide also. Okay, so that's why you have to remember the color changes as well as test for the gas liberated. Everything has to be kept in mind, right? So how can you see that the gas liberated is oxygen only? Okay, test for oxygen gas. Test for oxygen gas. You all know that oxygen is a very good supporter of what? Combustion. Okay, so a burning splinter when introduced into the jar containing oxygen gas, if it burns more brightly, then you can say that the gas liberated is what? Yes, oxygen. Okay, a burning splinter burns more brightly. A burning splinter. A burning splinter burns more brightly. Burns more brightly. Then you can say that the gas liberated is oxygen gas. Okay, why? Because oxygen is a very good supporter of what? Combustion. Burning. Without oxygen gas, there is no chance for any substance to be burnt. Isn't it or not? So, test for oxygen. A burning splinter, if it burns more brightly, then you can say that the gas liberated is oxygen. Means how you can identify this in your laboratories. That is also a very important thing. Here, when potassium nitrite is liberated and along with that oxygen gas is also liberated. Then, keep a glowing agarbatti in the test tube. If that agarbatti catches fire and burns more brightly, then you can say that the gas liberated is what? Oxygen gas. That's what burning splinter. Here burning splinter in the sense a glowing agarbatti or a glowing matchstick, anything you can take. Okay, so this is test for oxygen gas. Same like this, I just said all nitrate salts not only they may liberate oxygen, they may even liberate nitrogen dioxide also. You can take lead nitrate as an example. Okay, lead nitrate. So what is lead nitrate? It is a white colored salt. Okay, lead nitrate. If it is heated, we are learning about what? Remember, we are learning about thermal decomposition reactions. That means single substance splits into two or more by heating. Here also, nitrate is a single substance splitted into two or more substances. Same like that, if you take third example, lead nitrate, PbNO3 taken twice. What is this? Lead nitrate. If lead nitrate is heated, okay, then on heating, it gives rise to what? Lead oxide plus nitrogen dioxide plus oxygen. Here two gases are being liberated. Even nitrogen dioxide also liberated. You can see this color of nitrogen dioxide. Reddish brown in color. Okay now. Color of NO2 is what? Reddish brown colored gas. Okay now. Reddish brown colored gas. Okay, and test for oxygen you already have learnt. What is it? If you keep a glowing agarbatti in the test tube, near to the test tube in which the activity has been performed. Okay, if the agarbatti burns more brightly, then you can say that the gas liberated is what? Oxygen. Okay, test for NO2. NO2 is a colorful gas. It is having reddish brown colored gas. Okay, so you can identify that to be what? Nitrogen dioxide. So this is also a decomposition reaction. Single substance splits into three substances here. Okay, on heating. That's why it comes under what? Thermal decomposition reactions. Okay, and you can even take the example of potassium chlorate. KClO3 on heating, it gives rise to KCl plus oxygen. Okay, here also 2 KClO3 gives rise to 2 KCl plus 3O2. What is KClO3? Potassium chlorate on heating, it gives rise to potassium chloride and oxygen. Okay, this is potassium chlorate. This is potassium chlorate. On heating, it gives rise to what? Potassium chloride. Okay now, chlorate gives rise to chloride. Okay, and here we will be learning about one of the important topics of catalyst, introduction of catalyst also here. Okay, so this reaction actually requires almost around 300 to 400 degrees centigrade temperature is required. Okay, if you heat the potassium chlorate more than 300 degrees centigrade temperature, then it splits into potassium chloride and oxygen gas will be liberated only after heating it up to 300 and above temperature. Okay, but if you use a substance manganese dioxide, if you use as catalyst, okay, manganese dioxide MnO2 is used, then the reaction can be carried out very quickly. You need not to heat it up to 300 degrees and above 300 degrees you need not to heat. The reaction can be completed at 240 degrees centigrade only. That means liberation of oxygen can be observed at very low temperature of 240 degrees, and less than 240 degrees itself liberation of carbon dioxide can be visible to us. Okay, that means what? Here manganese dioxide is a chemical substance which is called as what? Catalyst. Then what is catalyst? You all should know about catalyst. Okay, a catalyst is a substance which is helpful for speeding up the rate of a reaction. What is catalyst? Remember catalyst. Okay, catalyst. What is catalyst? A substance which itself does not participate in the reaction but helps in speeding up the rate of a reaction. Okay, it itself does not participate in the reaction. Okay, manganese dioxide is not being used as reactant here, but in presence of manganese dioxide, the rate of reaction was increased. The reaction was speeded up. Okay, right? A substance which itself does not involve in the reaction, please remember, does not involve in the reaction but helps to speed up the rate of a reaction, which itself does not involve in the reaction but helps to speed up the rate of a reaction. Such kind of substances are called as catalysts. Okay, rate of reaction can be increased. That means the reaction can be completed quickly. Such kind of substances are called as what? Catalysts. Okay, so here manganese dioxide acts as a catalyst. Okay, in the reaction of potassium chlorate turning to what? Potassium chloride with the liberation of oxygen gas. This is also happens on heating. That's why it comes under the category of what? Yes, thermal decomposition reaction. Okay, so these are different examples for what? Thermal decomposition reactions. Okay, please note down everything. Okay, and do you know about potassium dichromate and ammonium dichromate? You know dichromate salts. Okay, now dichromate salts are orange in color. You can see them in the picture. Okay, you can take the example of fifth example. You can take ammonium dichromate. Very colorful salt it is. Ammonium dichromate. Okay, so ammonium dichromate will be orange colored salt. Okay, by heating that, the salt itself is combustible salt. You know, I think you know the difference between combustible substances and non-combustible substances. If you are going to take this potassium dichromate in a china dish, and if you are going to give a matchstick, a glowing matchstick or a burning matchstick, if it is kept in the ammonium dichromate substance, then it burns and it will be giving out what? A green colored salt. Okay, now green colored ash will be formed. So ammonium dichromate, what is the formula? NH4 taken twice, Cr2O4. NH4 ammonium, NH4 taken twice, Cr2O4. This is ammonium dichromate, orange colored salt. Ammonium dichromate. Okay, on heating, it gives rise to what? Dichromate, chromate salt and vapors, water vapor will form, and along with that nitrogen gas also will be liberated. But that chromate salt, okay, Cr2O4, chromate salt. This is what? Chromate. Chromate salt plus vapors of water plus N2 gas will be liberated. Here also single substance splitting into 3 substances. Okay, this is what you will observe is ammonium dichromate appears to be in orange color. Even potassium dichromate also orange colored. Okay, orange colored, very colorful salt. You can see that in the picture. Okay, orange colored salt gives rise to this chromate salt. Chromate salt will be green color. The ash appears to be green color. Okay, so on heating, it decomposes into what? Chromate salts and water vapor, and nitrogen gas also will be liberated. Nitrogen gas is also a colorless gas. Okay, you don't have any specific test for nitrogen gas. Okay, so here you need not to learn any test for nitrogen gas. So please note down this one. Okay, and you will be coming across certain reversible reactions are also there. Okay, reversible reaction like N2O4. On heating, it gives rise to 2NO2, nitrogen dioxide gas. This nitrogen dioxide gas, if you collect that in a gas collecting jar, and if you are going to cool the vapors of nitrogen dioxide, then you can get back nitrogen tetroxide. This is what? N2O4 is dinitrogen tetroxide. Nitrogen tetroxide. Okay, now tetroxide gives rise to nitrogen dioxide. Nitrogen dioxide. I already told you it is appearing to be in what? Reddish brown in color. Right? So like that. But this is a reversible thermal decomposition reaction. First, on heating, it turns to nitrogen dioxide gaseous form. But on cooling, you can get back. Okay, so this comes under what? Reversible thermal decomposition reaction. It's a reversible reaction. Okay, so like that, all these comes under what? Thermal decomposition reactions. Now we'll move on to the second type of reactions. Those are what? Photolytic reactions. Second type of decomposition reactions, photolytic reactions. Photolytic or photolysis. What is photolysis? Photolytic reactions. Photons means particles of sunlight. Okay, now particles of sunlight. That means in presence of sunlight, certain reactions will take place, and such reactions comes under the category of what? Photolytic reactions. Particles of sunlight are called as what? Photons. Okay, so if any reaction happens in presence of sunlight, okay, then it forms what? Photolytic decomposition. Best example for this is what? AgBr, silver bromide. It's a solid powder, yellow color. Okay, yellow colored solid powdered form. When exposed to sunlight, okay, when kept in sunlight, it gives rise to silver plus bromine, 2Ag plus Br2. Okay, so yellow colored substance turns to grayish silver. Grayish colored silver will be liberated. Okay, this happens in presence of what? Sunlight. That's why this comes under what? Photolytic reactions. Okay, this is first example, and you have only 2 examples for this. Second example, iodine crystals, I2. You all know that iodine crystals are which colored? Violet colored. Okay, shiny violet colored crystals, iodine. On heating, they gives rise to iodine vapors. Okay, violet colored crystals turns to violet colored vapors. Okay, when kept in what? Sunlight. This is not on heating. Better you write here what? Sunlight. Okay, why? Because they comes under the category of what? Photolytic reactions. Sunlight. Okay, iodine, violet colored vapors you will be getting. So these are the examples for what? Photolytic reactions. Okay, and we'll move on to the third category, that is electrolysis reactions. What are electrolysis reactions? If any reaction or decomposition happens in presence of electricity, then you can call them as what? Electrolytic reactions. Decomposition reactions. Electrolysis. Okay, decomposition. Third type is what? Electrolysis. Decomposition of a substance into its ions by passing electricity through any substance. You call it as electrolysis, isn't it? What is electrolysis? Decomposition of a substance into its ions. Okay, now decomposition of a substance into its ions by passing electricity through it. You call such reactions as what? Electrolysis reactions. Okay, so when you go for the examples of electrolysis reactions, electrolysis of water you can take. Okay, so H2O decomposes into H plus and OH minus ions. Okay, by passing electricity through them, they dissociate or decompose into what? Their respective ions. H plus ions are hydrogen ions and OH minus ions are what? Hydroxyl ions. Okay, here you need to take acidified water, because pure water does not conduct electricity. Please remember this point. Distilled water or pure water does not conduct electricity. Why? Because they don't have ions in them. Okay, that you write it as a note point. Distilled water does not conduct electricity. Why distilled water does not conduct electricity, whereas rainwater can conduct electricity? You will be getting daily life application questions, application based question. Okay, so distilled water does not conduct electricity. Does not conduct electricity because it doesn't have ions. Okay, because it doesn't have ions. It doesn't have what? Ions in them. It cannot dissociate. Okay. So you have to remember. So you have to take what type of water here? Acidified water. Means what? A little 1 or 2 drops of HCl or H2SO4 has been dropped in this water. Then it nicely conducts electricity and it dissociates into H plus and OH minus ions. Okay. Hydrogen ions and hydroxyl ions. Okay, this is in case of water. Okay, when you go for any other salt substances, salt water or anything, okay, then here mainly you have to focus, or questions will be asked when you conduct electrolysis process, you require 2 metal plates which are called as what? Cathode and anode, and you also require an electrolyte. Okay, I think you have idea about electrolysis process. You might have learnt in your lower classes. Okay, so at cathode what gas is going to liberate, and at anode what type of substances are going to liberate? You will be getting questions on that area. Even in Olympiads also, or in NSO, or in any type of competitive exams like NTSC and all, you have to focus on that particular area. Everybody can understand, okay, but understand the concepts, but the way of questioning you have to understand, where you have to focus more, that is required. Okay, so here if you take example 2, sodium chloride. Okay, aqueous sodium chloride, if it is taken as electrolyte, and if you perform the process of electrolysis for this, okay, if you perform the process of electrolysis, it dissociates into Na plus and Cl minus ions, and if you are taking aqueous solution, in this water also will be there, so the water present in that also gets dissociated into H plus and OH minus ions. Okay, So now at cathode you will be getting H2 gas, and at anode you will be getting chlorine gas and sodium hydroxide as byproducts. That point also you have to remember. At anode, what you are going to get? Cl2 gas. Okay, Cl2 gas, and along with that you will be getting NaOH as byproduct. Okay, now NaOH as byproduct. Okay, when aqueous NaCl is electrolyzed, the substance liberated at cathode is hydrogen, and the one which is liberated at anode is what? Chlorine. Okay, and NaOH can be obtained as byproduct. Please remember. Suppose if you take molten NaCl, then in that water will not be there. Okay, now molten NaCl. What is molten NaCl? Liquid form of NaCl in which water is not present. In such case, by electrolyzing molten NaCl on electrolysis, what you are going to get? Here also you will be getting Na plus and Cl minus ions. At cathode, anytime you please remember, if water is present, then hydrogen will be liberated at cathode. If water is not there and the electrolyte is taken in the form of a molten state, okay, then please remember, at cathode the particular metal ions gets deposited. Okay, sodium metal deposition you will observe. Okay, at cathode sodium metal deposition means what? The ions of sodium gets coated onto this cathode. Sodium metal deposition. Please remember this point. Okay, sodium metal gets deposited, coated on cathode. Okay, and at anode you will be getting chlorine gas. Okay, so these are the main areas where you will be getting questions. Okay, at cathode what is the substance you are going to get, and at anode what is the substance you are going to get. If you take molten electrolyte, what kind of products will be coming, and if you take aqueous electrolyte, what type of products will be coming. Okay, you all have to identify and remember, like you can expect questions on this area, right? So this is the third type of decomposition, which is called as what? Electrolytic decomposition. Okay, so please remember these points. Okay, like this, any example if they have given also, you can easily write. Okay, continuous learning is required, dear children. Please keep watching my videos. I am stopping this video up to here. Okay, in the next coming video we will be learning about chemical displacement reactions. Means what? Substitution reactions. Okay, in that also we have lot much is there to learn. Okay, I always say your hard work is your superpower. Keep learning, keep doing hard work. Happy learning. Thanks for watching. Bye.